See, like J Advanced in the last 5 years have asked really interesting problem from 3D whose importance cannot be avoided. Even last year question paper was based on the S-sphere, which was of course very fundamental. So I have taken those fundamental ideas to address some recent problems. Consider a point P in xyj space and the curve z equals y square. So we know like the curve z equals y square. So let's say roughly if this is y z and x-axis, okay, it's tough to, so we have got y-z plane over here, something like this, just to get a feel of the question. So hence roughly we can draw the curve z equals y square is this. Okay, so this is z equals y square. In extension of q p extends the xy plane at the point R. So as q changes over the parabola, the R will trace a curve and we have to find locus of this curve. Now this is not that challenging question, but you have to visualize what exactly is happening. So understanding the problem is must. Once you get this, the solution becomes obvious. So we'll start, let's say the point R is having coordinates alpha, beta and 0. So basically we have to find locus of this point. So we need to a relation between alpha and beta. Now clearly we can take a variable point on the parabola because on this plane x coordinate will always be 0 because you are not moving along x direction. It's a yz plane. So any random point can be written as 0 t comma t squared. So point q is known, p is known, hence we know the equation of line. So that will be x minus 2 over 2 minus 0 is y minus 0 over 0 minus t equals z minus 1 over 1 minus t square. Now we know this line intersects xy plane at alpha, beta, 0. So alpha comma beta comma 0 must satisfy this equation. So alpha minus 2 by 2 equals beta by minus t equals minus 1 by 1 minus t square. And that gives alpha minus 2 equals minus 2 by 1 minus t square and beta equals t by 1 minus t square. So with little manipulations, 2 minus 2 by 1 minus t square, this gives 2 minus 2 t square minus 2 by 1 minus t square minus 2 t square by 1 minus t square. So we know alpha and beta in terms of t, and t is a real parameter. So t dances on the parabola. As t changes, the point dances on the parabola. So now it's just an elimination of t from these two equations. And how to eliminate? That's not very difficult because we can divide this equation alpha by beta, which gives minus 2t. So t becomes minus alpha by 2 beta. I'll put this in one of these equations. So let's say beta equals t minus alpha over 2 beta by 1 minus t square 4 beta square, which gives beta equals minus alpha by 2 beta over 4 beta square minus alpha square 4 beta square. And after cancellation, 2 beta we can cancel. We have minus 2 alpha beta over 4 beta square minus alpha square. Even we can cancel beta, provided alpha and beta is of course 0 comma 0 is also satisfying the equation, right? So when you're cancelling, make sure like alpha beta 0 0 is also one of the solutions. And that gives very nicely minus 2 alpha equals 4 beta square minus alpha square, and which can be written as alpha square minus 2 alpha minus 4 beta square equals 0. So alpha into alpha minus 2 4 beta square equals 0. Of course we can't take alpha as 2. Why? Because the reason if we'll take alpha as 2, okay, you can see the denominator is becoming 0. So the locus will not be defined. Alpha cannot be 2. So hence locus is all point which satisfy this equation, x into x minus 2 minus 4y square equals 0 with x coordinate cannot be 2. So this is the locus. Now this is nothing but an hyperbola. So x minus y whole square minus 4y square equals 1 on xy plane. This represents hyperbola with the only restriction x cannot be 2. So in this hyperbola the point 2 comma 0 is removed passing through origin. And this point will be open, right? 2 comma 0 xy plane is coming to be hyperbola. Let's move to the next question. As you can clearly see, for OAB the z coordinate is 0. So these 3 points lie on the xy plane. And it's easy to plot them. We have root 2 0 0 0 root 2 0 and 0 0 0. So let's say this is x-axis, y-axis and z-axis is above. Okay. So now we have a sphere of radius root 6 in xy space. The center of a sphere has positive z coordinate, so it's along this direction. And the sphere is tangent to OA. So if I'll take a cross-section view from upward, from the top, we'll get a circular cross-section. Okay. So the first challenge will be to find the radius of this circle. Of course, this is a sphere, so the sphere is touching at this point. Once you know the radius, we know the coordinate of this point P, let's say, as well, which is nothing but r 0 0. Similarly, by symmetricity, this is going to be 0 r 0. Now finding the radius is not that difficult, because we know the equation of this line, which is given by x plus y equals root 2. Since z is 0, so the question boils down to, since z is 0, so hence the question boils down to just 2 decays, at least to start. And now the distance from center, which is r comma r, must be equals r. So we'll use r plus r minus root 2 over root 2 is r, which will give 2r minus root 2 equals root 2r mod. So 2r minus root 2 is plus minus root 2, which gives us two values. 2r equals root 2 plus minus root 2r, plus 2 minus root 2 plus root 2 is root 2r. So r we are getting as root 2 by 2 plus root 2, or r is root 2 by 2 minus root 2. Now what is the significance of these two answers? Let's see. Because there are two circles which will be in the same ambience. So there can be other circle which is tangent to the line, having, the center is still r comma r and distance from this line is r. So mathematically you are getting one in circle and x circle. Of course the radius of in circle will be less, so this will be the answer for in circle. This will be x circle answer. Now some of you might feel like still there can be cases, if I extend this line, there will be circles over here as well, right? Or there as well. So why mathematical equation is not able to capture this? The reason is that the coordinate of this circle will be now of opposite parity. So if it will be 1 plus r, then other will be minus r. So this automatically takes care of this, because if it is 1 comma minus 1, that will be minus 1 comma 1. So if we put that conditions, we'll get the other two set of equations. Anyway, that was not the point. Once we know the radius, the coordinate of the center of the sphere can be found very tactically. Let's see how we can do this, because now we know a point on the sphere, because a point on the circle is definitely a point on the sphere. So this point is known to us, which is r 0 0, and r value just I have told, r will take this one, the smaller one. And now we know the center of the sphere is somewhere. So this is not the center of the circle, for a sphere I am talking. So now the situation is something like that. We have a sphere and cross section as a circle, and the point on the circle is r 0 0. The center of circle is known r 0, right? So let's say the center of a sphere is S. So now I can easily calculate using Pythagoras theorem. Now r square value we know 2 by 2 plus root 2 whole square, and that directly gives the value of alpha, which will come to be Okay, so r we can even rationalize. So we have 2 plus root 2. If I multiply with 2 minus root 2, and this expression is going to be 2. And we have 2 root 2 minus 2 over 2. So that gives root 2 minus 1. Of course, you could have found the radius of in circle also using delta y semi-perimeter, which will give you a faster calculation. The reason I did this is to expose you to different techniques. Once you know the r, we know the value of alpha from here, and hence the coordinate of a sphere that we will be getting is root 2 minus 1, root 2 minus 1, rr, and alpha root 2 plus 1. So this is the first part of the problem. The second part was find the volume of portion of a sphere which is above xyz. Okay, so now to find the volume of a sphere, we can take a small cross section, circular cross section, and let's take a small height of dz. So that volume will be, if the radius of the circular cross section is r, so it's going to be pi r square dz. And this will integrate from z equals 0 to z equals root 2 plus 1 plus root 6. This can be done smartly as well, because if we'll shift the sphere and let's say center to be 0, 0, by shifting the axis, the volume comes to be just minus root 6 to root 2 plus 1 pi times 6 minus x square dx. And this integration is quite easy, which you can do. And we'll get pi by 3, 11 plus 13 root 2 plus 12 root 6 as the answer. Let's move to the next question, and here is an interesting question again. Let's move to the next question. We have 4 lines in the space. The first part is we need to find a line that intersects both L1 and L2. The second part is you find a line that intersects L1, L2, L3. And the third one is find a line that intersects all the 4 lines. And that's a very interesting question, because in each case not only you have to find the lines, but also you have to comment on. So in each case not only we need to find the line, but also we need to comment on number of such line possible. Okay, so what do you feel for the first one? So x1, y0, any random point in the line can be taken as 1, 0 and t. For other line, y is 1, z 0, so x can take any value. Let's say x is u, 1, 0. Now clearly there will be infinitely many lines, because I can take a random point p on the first line L1. Clearly there will be infinitely many lines, because I can take a random point p on the first line, random point q on the second. As p changes, q changes, this will keep on giving me infinitely many situations. So one such line you can take, let's say 1, 0, 0, and let's say 0, 1, 0. And hence we can write the equation of 1 among infinitely many line. X minus 1 by 1 minus 0 is y minus 0 by 0 minus 1 is z minus 0 by 0 minus 0. What does this signify? The z coordinate of this line must be 0, right? Because if z is non-zero, this term non-zero by 0 will not be defined. So for the first part, there will be infinitely many solutions. A better question that you can solve is, as point P moves along this line and point Q moves along that line, okay, the line PQ will generate a surface. Find the locus of that surface. Okay. Let's come to the second part. Now we have more guardianship over here. Now we want the number of lines which will intersect these 3 lines. So again, we can start with the number of lines intersecting 2 lines, so L1 and L2 in the same format, 1, 0, t. Let's take a parameter u1, 0. Both t and u is free to move, so they are reals. Now we want this line to intersect a third line. And what's the beauty of third line? L3 is z equals 1 and x equals 0. Of course, y can be anything. So as you have seen, the general equation of any line joining 2 points on the L1 and L2 can be written as x minus 1 by u minus 1 equals y minus 0 by 1 minus 0 z minus t over 0 minus t. Now in turn, if this has to intersect another line L3 z1 and x equals 0, so z equals 1 and x equal to 0 must satisfy this. What about y? Y can be any real number. So put z equals 1 and x equals 0, we'll get minus 1 by u minus 1 is y by 1 equals 1 minus t over minus t. And now we got a relation between u and t. Right? So t equals u minus 1, u1 minus t. And y is given by 1 minus t by minus t. Now what does this relation signifies? As you can see, like u is completely free variable and t is completely free variable. So there is a relation between u and. Once you got t and u to be related with this relation, we already know y is going to be 1 minus t by minus t. So now t can be written in terms of u. So we know the line is passing through 1, 0 in some function of u and direction of u minus 1, 1 and again some function of u. So just we have a single parameter of u, right? So if u is changing, there will be infinitely many lines possible. So even in the second conditions, we will have infinitely many possibilities. Now I want you to solve the third condition by yourself in the similar fashion. For the third condition, we have a line that meets all the 4 lines, and that's again interesting case, because for the first 3 lines, we already know a random line with parameter u. Now this line must pass through other line L4, which is x equals y equals minus 6z. So this line must satisfy x equals y equals minus 6z. So once you'll do this, so you take x, y, and z coordinate of this general parametric form and satisfy the third equation. So now a random point on a variable lines which is passing to all 3 must satisfy the another constant x equals y equals minus 6z. And you can see from here the t in terms of u is kind of non-linear. Hence we expect 2 values of u. So for the last part, you will get exactly 2 such lines. And the calculations is left to you as an exercise. Let's move to the next question. We have to find a point which is equidistant from all the 4 planes. Now clearly any point which is equidistant from x, y and z plane will have a coordinate alpha, alpha, alpha. And now the distance of alpha, alpha, alpha from this point is going to be 2 alpha plus 3 alpha plus 6 alpha minus 36, and the usual distance of a point from a plane formula of 2a square plus 3a square plus 6a square, and this is going to be mod alpha. From here you will get 2 values of alpha, and that will give the answer. Now clearly this approach is not totally correct. Why? Because distance of a point from a xyz plane is not alpha. Let's say we have a point alpha, comma alpha, comma alpha. The distance is not alpha. In fact, it is mod alpha, because we can have point even 1 minus 1 1 or 1 1 minus 1 or minus 1 1 1. All possibilities minus 1 minus 1 minus 1. So we have 8 possibilities for this. So for all these 8 points, they are at the same distance from xy plane, which is of magnitude 1. So that you have to be alert. So while solving this, if you directly blindly solve this, you will get the values as 2 to 2 and 999, which is clearly the subset of the entire solutions, because we can have other possibility as well when the point coordinate is alpha minus alpha alpha. So for the points which are having same distance from these three planes, not only we have to consider x, y equals g, but also we need to separately consider x equals y equals minus g. Okay, or x equals minus y equals g, or minus x equals y equals g. Each of these lines contains two solutions of point in similar manner. And if we'll do all calculations, the number of solutions that we'll get is 7 solutions, which is 2 to 2, 18 minus 18, 18 and minus 18 by 7, 18 by 7, 18 by 7. This you can cross check just by solving this repeatedly for this situation. I hope you must have enjoyed, and there is a question for you to try at home. You have to find the equation of a sphere. So give it a try. Or you can just write a point on the as a center of a sphere in parametric form T.